Dun da da da! Chapter 12, Matrices, 12.4, Part 3, Curve Fitting. It's our last video in this amazing series about Chapter 12 in our book. And we have some special guests today. They're fresh from the set of Game of Thrones. How are you guys doing today? Very fine, thank you. Hello, children. Hello. You guys have anything you want to say? Yes, a Lannister always pays his debts. Alright, today we're just going to do three sample problems from the book, and they're similar to problems you guys are going to do in homework. And they're all curve fitting problems, which is when we're given some points and we have to find the equation that goes through those points. And it might sound a little bit like regression, but regression is when we have data that doesn't necessarily all lie on the same curve. Here, these points all lie on the same curve. Alright, so the first problem is about a parabola. So we're on page 820 of our book, and this is number 38. And we have to find the equation of a parabola. The generic form is ax squared plus bx plus c, and it has to go through these 3 points, which are 1, 1, 2, 1, 3, 2. So basically what we have to do is figure out what a, b, and c are that make this equation go through these 3 points. And we're going to do this by first setting up a system of equations. And this system is going to be made up of equations that we get by plugging in the x and y into this equation. And then our variables will be the a, b, and c. So for example, our first equation, we'll plug in 1 for x and 1 for y. So we'll get y, which is 1, equals ax squared, so just a, b times x, which is bb, and plus c. Because if x is 1, then we'll just get 1 here and 1 here. The second equation, y is 1 again, but now a is 2, so we'll have, x is 2, so we'll have a 2 squared, which is 4a, plus b times 2, which will be 2b plus c. And then our third equation will be 2 for y and 3 for x. So we'll have 9a plus 3b plus c. And now we just have to solve this system of equations for a, b, and c. And we're going to use the strategy from last section, which was to find the coefficients matrix, find the constants matrix, and then do the inverse of the coefficients matrix times the constants. So coefficient matrix is 1, 1, 1, 4, 2, 1, 9, 3, 1. And our constants matrix is 1, 1, 2. And that's our A and that's our B. And remember, we're trying to find the X matrix, which will hold the values of A, B, and C, so that constants times the solutions equals, coefficients times the solutions equals the constants. Alright, so this is where we're going to break out our calculator, and, well, actually our solution is going to be x is A inverse of B. Remember that to solve this we would multiply both sides by A inverse. Alright, so now we're going to get our calculator, and we're going to go into the matrix menu, and we're going to edit matrix A, and it looks like I already put in the coefficients matrix, which is 1, 1, 1, 1, 2, 1, 9, 3, 1. First thing we want to do is probably check that that matrix has an inverse, and remember we do that by checking the determinant. So we'll do the determinant of A, and that gives us -2. Remember, we don't want that to be 0. Alright, now we can go and edit matrix B, and that's a 3 by 1 matrix, but it is holding 1, 1, and 2. And now we're just going to do our A inverse times matrix B. And that should give us the solution, which is 0.5, -1.5, and 2. So those are our A, B, and C. So our equation is going to be 0.5 x squared plus, it'll be -1.5x plus c, And there is our equation of the parabola that goes through those 3 points. All right, there's another problem where we have to do a very similar thing, but this time for a cubic. This one I'm just going to set up for you guys, and I think you can do the calculator part on your own. If not, I don't know, you're in some trouble. But 42, it's now a cubic equation. So for a cubic equation, our general form is going to be ax cubed plus bx squared plus cx plus d. So now we're going to have 4 unknowns, which means we have to have 4 equations, which is why they're giving us 4 points. So our equations are going to be -3 equals just a plus b plus c plus d, because x is 1 in this first point. And then our second equation will be -2, and then we'll plug -1 in here. So -1 squared will just be positive. Oh, I'm sorry, this will be cubed. This will be negative, because -1 cubed is -1. So negative a, and then positive b, and then negative c, and then positive d. And then y will be 6, and x will be 0, so we'll just get d there. And then the last one, 0 is y, and then 3 will go in. So we'll have 27a plus 9a plus 9b plus 3c plus d. And those are your equations, so your coefficient matrix is going to be 1, 1, 1, 1, -1, 1, -1, 1, 0, 0, 0, 1, and 27, 9, 3, 1. And then that's your A. Your B will be the constants, -3, -2, 6, 0. And you'll just go on your calculator and do A inverse times B, and you'll have your solution. All right, the last one I want to show you is a little bit tricky, and it might look a little bit scary at first. Nothing scares a Lannister. All right. So this is number 46. Here's the crazy equation they're giving us, which is f of x equals a e to the x plus b e to the -x plus c. And our 3 points are 0, -1, ln of 2, 4, ln of 3, 7. The only thing that might scare us is a dragon. A what? A dragon. Dragon! Alright, don't be afraid of this. This isn't like a dragon at all. We're just going to write the equation with a y. Oopsie. A e to the x plus b e to the -x plus c. And we're going to plug the points in just like we did before. So we're going to have -1 equals a e to the 0 plus b e to the -0 plus c. 4 equals a e to the ln of 2 plus b e to the -ln of 2 plus c. And then 7 equals a e to the ln of 3 plus b e to the -ln of 3 plus c. Don't be afraid. All right, we're just going to rewrite these equations with numbers instead of expressions with the natural number e. And we can because, for example, e to the 0, we know what that is. That's 1. And e to the -0, well, -0 is just 0, so that's 1. So -1 is just a plus b plus c. That's our first equation. Now in the second equation, we have e to the ln of 2. If you recall from last chapter, chapter 5, that e and ln are inverse functions. So these are gonna undo each other, and we're just gonna get 2a for this first expression. Now here, this one's a little bit tricky. We have to bring this negative up as an exponent on the 2, and that becomes a 1/2. So we have e to the ln of 1/2. E to the ln, they undo each other, so we'll have 1/2 of b plus c. And a similar thing happens in this last equation, where we'll have 7 equals, this will just become 3. This will just become 3 to the negative 1, which is 1/3. And that's just c. And so our coefficients matrix is 1, 1, 1, 2, 1/2, 1, 3, 1/3, 1. And our constants matrix is negative 1, 4, 7. And we'll put those in our calculator, find the inverse of A, multiply it times B, and we'll have our solution.